Hey, what's up everybody? This is Ray and welcome back to our Objective-C video tutorial series. This time we're going to take a look at Objective-C initializers. Okay, so here's the basic syntax for Objective-C initializers. You're going to see this pattern again and again, and so I just wanted to go over it bit by bit. So first of all, on the far left, you're going to have a dash because an initializer is an instance method. Next, the return value of initializer should be, in good practice, instance type. Instance type is a special keyword that means the type you're returning is an instance of the class that you're calling this method on. So it's used in initializers to say basically I'm returning this class. Then for your initializer you can treat it just like any other method. You give the name of the initializer and you can pass in whatever parameters you might want to have on it. Okay, that's the first line. The next line says if self equals super init. And there's two parentheses around the if self equals super init part. So what this is doing is super init is calling the superclass's initializer to let it do its thing. And that's going to either return nil if it didn't work, or an instance of the class if it did. It assigns that result to self, and then the two parentheses are to basically make sure that that succeeded. If it did succeed, it goes inside and you can do whatever you need to do to set up your class. And here's an example where it's setting two instance variables to the parameters that are passed in. And the last thing you want to do is you always want to return self at the end of an initializer.
Okay, so I'm in the date calculator project we've been working with in the previous videos. If you don't have this, just grab the starter project from the link below. So notice in this project that there's no initializer. You just call the default initializer here, and then you set two properties. It's a lot more convenient instead of calling the initializer and then setting two properties to just modify your initializer, create a custom initializer that takes these two values as parameters and sort of gets everything set up. Let's go ahead and create a custom initializer. So I'm going to open up date calculator and I'm going to call and make a new method, and it's going to return an instance type, and it's going to be called init with his age. It's going to be first parameter is a float, his age. Second part of the method name is going to be his name, and it's going to be ns string, and we'll call the variable his name. Okay, now I'm just going to take this and I'm going to move it over to the .m file. And then I'm just going to do the standard boilerplate for creating an initializer. So I'm going to do if self equals super init. And at the end of the method, I'm going to return self. And inside here, I do the meat. So the meat is I'm going to set the his age instance variable, which is automatically created for you by declaring the property, equals his age. And I'm going to set his name equal his name. Now, here's something you may wonder. You may wonder, why did I do it this way, saying his age equals his age, instead of something like this? I could do self, that's the name of this instance, set his age equal to his age. I also could have used dot notation, it's the same thing, his age equals his age. So why didn't I do it this way, and why did I do it this way instead? The reason is it's a little better practice to do it this highlighted way instead. And the reason is because, remember, when you use properties like this, you are calling a setter. And this setter happens to be automatically made for you by the compiler because of the property. But you can override the getters and setters with your own method implementations. And if you do that, you might make the method do something weird in theory. You could make it, set the value and also make a database call. It could set the value and open a file. And because of that, when you're working with initializers, you basically want to do the simplest thing possible to reduce the likelihood of failure. So just simply setting the instance variable makes it so you know you're not having any other side effects happen. You're just directly setting the value, and that's all you need for an initializer. So the general practice is you want to avoid side effects in initializers, and hence you want to avoid properties. Okay, so back to things. We've created our initializer here. So now I can go back to view or app.delegate.m, and I don't need this code anymore because I'm going to call my new initializer. And I'm going to pass in the values 34 and the value for his name. And now when I run it, Everything runs just as before, except now our code's a little bit cleaner.
All right, that's it for this video tutorial, a real short one, and we also have a real short challenge for you. All I want you to do for this one is going back to the temperature converter sample we've been working with. And again, if you skip to this video, you can pick up a starter project for it. I just want you to convert and make your own initializer. And I want it to be called init-with-location. It takes in a string and it sets up the property or instance variable for that location to whatever you pass in here. And then modify your code in app delegate to test this out. So that's it for this video tutorial. I hope you enjoyed it, and we'll see you next time.